press record and then share my screen. There we go. Okay, and we will play from the start. All right, it's all yours, Jen.
Okay, so I think I kind of spoke to most of this. The resources that I mentioned at the bottom are some of the ones that we've talked about using fairly regularly when we're looking at what students need in the elementary years for moving that numeracy development along. And counting, we decided to start with just because it is such a foundational piece. I found as a grade 2-3 teacher, it was I was working with kids on counting all year long. It's just such a huge piece that leads to so many things later in their math development of understanding. So yeah, anything else you want to add?
Fabulous. Yeah. No, not at all. Just again, recognizing BCIMT is providing us with, you know, the resources and the time to do this. So thank you to them as well. Okay, let's see if this will work. Oh, interesting. Oh, this is, oh, down here maybe? Yay. Okay, so one of the things that we're, unless this went way ahead, no, we didn't. Okay, you can tell it's our first one. The first thing we want to say is we love these resources and we love these diagnostics because we are looking for student understanding, but we're also looking for the appearance of understanding. So a lot of our kids will actually look like they understand, but they don't. And so we want to uncover that and make sure that they actually do understand. So we want to get them to do, and we want to get them to say something that really shows their knowledge, not just the appearance of knowledge. And we want to just demonstrate that by collecting evidence that they do really understand. First steps in mathematics, and it's known as FSIM or FISM or different ways people say that. These are the key reasons for this study. And the study took about 10 years, and I think they worked with 10,000 kids, and they developed these and I think is standardized their assessments as much as they can. The first one is that students may get the right answers for the wrong reasons. So we're really looking for that. Is a student appearing to know the right answers? We also know that good questions and tasks are provoking students to show us what they know and understand. We also know that if the kids understand the mathematics, they're going to be flexible thinkers and make better decisions. But we also want to see the patterns in their student responses to help us plan. So we have that formative assessment. We know what our next steps will be. And these are the patterns within your classroom and within the individual students. So understanding has to be in place to ensure that children are not just imitating procedures. And we know that we need to look for that quite often, or saying the words that they don't really understand. These are quotes, and this is the final one here. There are milestones or hurdles in children's growth of understanding, and they are insights rather than facts or procedures. And this is a great quote from Kathy Richardson. She's definitely someone that you want to look up and take a look at her website and her books, because they're fantastic. Okay, I think I stole, did I steal your slides? Did I just like keep going and present yours? I think I did. Okay, well, thank you. So counting is foundational. Jen and I keep saying this over and over, so we wanted to make sure we put that as a title on the slide. For those of you who are teaching older grades or think that counting isn't necessary in your grade, I teach grade 5 and I am assessing counting all the time. This is just a nice little graphic that shows how the progression works. So we're starting with the counting, seeing 1 and 1 and 1 and 1. We start to supertize when we start to see things together, seeing 3 and another 2. Then we get to decomposing, where we're able to use our subtraction skills and decompose a number into, so our thinking is a lot more flexible, which is going to lead us to our adding and subtracting. And so what we really want to make sure is that when you have a child who is having difficulty with adding and subtracting, you really need to go back to the first part, which is the counting, and see where the gaps are, where any misconceptions might come up. Okay, this is still me because I did all yours. So there are numerous people who have developed numerous names and for the counting principles. And I know that I came late to knowing that there was even counting principles. I thought counting was counting. And if a kid could count, I thought I just marked a checkbox and thought it was good. But there are different people who have different ones. We're going to show you a few. This one is, I think, from Bomberger, and have probably, this is also from Pearson, correct, Jen?
I kind of melded a few together, and yeah, to make it a bit simpler today. Yeah.
Yes, and I think that's what keeps happening is people keep making theirs. But we're going to look at all these different principles. These are the fancy names. That's what I call those ones, the fancy name ones. First Steps has 5. These are the ones that we're going to use today. So that each object has to be counted, must be counted, touched as the numbers are counted. The numbers must be said once and in order. Starting point and order in which the objects are counted does not affect how many there are, and the arrangement does not affect how many there are, and that the last number said tells how many are in the whole collection. Now, these seem very straightforward, but once you start looking for them in children, they're going to jump out a lot more for you. Kathy Richardson, this is one of my favorite books. She has many counting principles, many things for you to look for. So if you wanted to look at that book or purchase that book, it's not expensive, and you can make a checklist for yourself of all these different ones here. Okay, let's take a look at Michael. What I want you to do when we're watching this video is kind of see what you notice about counting. Oh, I'm going to stop because I just realized, Jen, that I'm not going to be able to make this bigger. Do you think it's going to be okay this small?
Yeah, I think especially this video is fine. Yeah.
Okay.
Yeah.
Please know that this, again, will be on the website, so you can watch this many times. And these videos are in the Google Slides, so you can make it as large as you want. So we're going to look at Michael, and he's going to count for one of the people who are studying counting for the First Steps in Mathematics.
We don't have sound. No sound, Deanna.
Well, that's fantastic. No sound. Okay. If I make it really loud, can we try that? Oh boy. Is that any better?
No sound.
All right. So what I'm going to do is I'm going to stop sharing this for a second. I am going to go off of my AirPods. Thinking that is the difficulty.
Oh yeah, maybe.
Thinking that's a difficulty. So thank you for your patience as we go through this. Now I'm going to share my screen again.
There's also some advice in the chat that might help.
Oh, we can't see the chat though, Josh.
I can see sharing your sound from the top bar while you're sharing, or check the audio option when sharing the screen.
Right. Okay. I think I'm just going to get rid of my AirPod and let's try it this way. I'm really hoping this works because it's a great video.
We need to find out how many Cookie Monsters there are.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, should we start again? Because we don't want to count anyone more than once. Let's start here.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11.
That audio work? It did. I can see by your smiles. Okay, so just for a moment, just think about what you noticed there. And if you could go to the chat, and we're going to do, and I've learned this from many presenters, we're going to do a thing where I just want you to type, but don't hit enter until I say go. So if you can go to the chat and type in, what did you notice about Michael's counting? What misconceptions did you see? What were his strengths? Just one or two. Okay. Ready? And hit enter.
Fabulous. 1-to-1, no 1-to-1, can say the numbers. Fabulous. Okay, we're gonna move on because this has got to be really fast. Okay, so once again, these are the some of the counting principles we're going to be looking at. So we're looking at him being able to name them, saying them in the right order, and also having that 1-to-1 correspondence.
But what did he not have? What was his next step?
Yes, Jen, what didn't he have?
Yeah, so he kept counting. So he doesn't understand that cardinality, that the last number says how many there are in all, and that's why he continue to count. So you're probably, we're hearing some of these names of counting principles more and more in the last couple of years. But these are the things that you want to be kind of watching for as far as behaviors when kids are counting. Sometimes you have to watch so carefully. I found that I've had to almost video kids at times to be able to catch some of the misunderstandings, because like he did, he went so fast. You have to just really be paying attention and knowing what to watch for. So these are some of those watch fors.
And once the teacher starts doing the pointing, we know that he doesn't have that 1-to-1 as well.
Yeah.
Okay, Jen's going to talk to us about counting and cardinalities.
So I would say this is probably the biggest misconception that kids have in the early years around counting. And I've actually seen this misconception all the way in grade 7. I've had grade 7 teachers send students to me saying they're struggling in math, they can't figure out what's going on with them. And I've done some of these first steps in math tasks and gone all the way back to understanding counting. The idea of cardinality is that when you're counting, you're understanding that the number that you say tells how many you've counted so far in that set. So Deanna, if you just want to kind of slowly click through these slides, often what kids will do is, or what they think is that they're saying number names kind of like they're saying the alphabet, and they see numbers almost as labels rather than representing that whole quantity that they counted. So for instance, here, if they're thinking about 7 dogs, or they count and they're saying 1, 2, 3, 4, 5, 6, 7 when they're counting the dogs, they're seeing that 7 as a label, almost like the same way you could label it as dog G or giving the dog a name. They're thinking of 7 as naming that 7th dog. So click again, Deanna. Yeah, so what we want kids to understand is that as they're counting, when they say the number 5, they've just counted 5 dogs. Number 6, they've now counted 6. So it's including all of the dogs that they've touched, not just that last dog. And I think this often happens because parents, and we did as teachers before we kind of really understood counting, parents spend so much time asking their kids to count out loud. And I hear it all the time in primary. I hear kids coming up to me saying, I can count all the way to 100. But then when you actually watch them count quantities or sets of items, they don't have that understanding of what that number actually represents. So yeah, that's kind of the point. Sometimes students learn ideas that we don't intend to teach them. And so when we're focusing so much on just that choral counting without having the counting collections for them to practice with, then they do form those ideas, you know, about counting that where we have some pieces missing. So we don't necessarily have to add this to the chat right now, but if you could just reflect on when you count in front of kids, like if you're counting out papers or pencils or whatever, or do you line things up? Do you always start from left to right? Go ahead, click it again. I think there's another one that comes up. Are we always just counting that one way? Do we show kids that, well, you could start on the right and count to the left, you could start in the middle, but as long as you're counting all of the items? Is this maybe sometimes influenced by reading and writing? When we're skip counting, what do we like? How do we model that for kids? in class. So yeah, there's lots of misunderstandings that can develop in the early years. So we have to just kind of pay attention when we're counting in front of kids to be modeling what we want them to understand about it.
Okay, so these are the 5 that we're going to look at. I'm going to take you through a series of videos. And what I want you to do, we're going to show you this slide each time, so you don't have to memorize this right now. What we want you to do is look at the video and decide which of these counting principles, could be more than one, is the student demonstrating and which ones are they struggling demonstrating. So we're going to start with Kia.
Count by 2. 4, 6, 8, 10, 18, 20, 19. That's a lot. All right, we'll count them by ones and see how many are there.
It's hard to count by ones.
1, 2, 3, 4.
Oh, yeah.
Go. Now count them by 2s. Again, Kia, when you counted by ones, how many did you get?
13.
When you counted by 2s, how many are there?
Yeah, because we're going to come right downstairs.
Yeah, if you can.
6,
So how many do you think are there?
18.
Okay, so when you count by ones, you got...
Oh, 13.
Okay, and when you counted by 2s, you got...
So loud. Okay, so this is your opportunity in the chat. Once again, don't hit enter until I say so. But, well, let me just go to the next slide. This will help you out. Oh, the slide's not there. So let me go back. That's okay. So here's the different things. What is she having difficulty with, and what are her strengths in counting right now? Okay, if you can write those 1 or 2 thoughts. Okay. Yes, it was hard to hear, unfortunately. Jen and I talked about we want to make new videos. All right, so I'm seeing lots of the same theme there. One-to-one correspondence is there, stable order, but definitely missing the conservation of the count. So the fact that she has to count every single time is a big red flag for you. But also she's demonstrating that she's not counting to find out how many each of those ladybugs she counted as 2 and she counted as 1. So there's lots to work on there with her. Did you have anything else you want to say on that, Jen? I know we're rushing through.
I would just say another thing I often see with kids when they're counting things 2 at a time is if it's an odd number of items, that they may count 2, 4, 6, 8, and then if there's one more, they'll touch that one more and say 10 instead of 9. So yeah, you'll start to see when you start watching kids counting, you'll see typical like misconceptions that come up.
Absolutely. Okay, let's look at, are we here? Oh my gosh, look at me go. This is why you didn't want to be the person sharing your screen, right, Jen? Okay, let's try this one with Joseph.
6, 7,
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25,
Stop. Keep your hand on 26, finger on 26. If you keep going, how many do you think you'll get?
36.
Okay, keep going, let's see. Oh, 1 minute, stop. You've got 26 there. How many did they get when they counted by fives?
35.
Okay, and you think there might be 36 if you count by ones. Okay, you up to 26?
Yeah.
Go.
27, 28, 29, 30, 31, 32, 20, 33, 34, 35.
So do you get the same if you count by ones as you count by fives?
Yeah.
Okay, you did that time. Will you always?
No.
You don't?
No.
7, 14, 21, 28, 35.
How many did you get when you counted by sevens?
5.
Pardon?
35.
How many did you get when you counted by fives?
35.
How many did you get when you counted by ones?
35.
Now, is that just a coincidence, or do you always get the same?
You always get the same because there's 35 cracks.
That's a fabulous video showing that it's amazing how he could chant the multiples and the counting. But at the beginning of that, oh, I'm not supposed to give that away, am I? Okay, so in your chat, if we go back to our observing counting, if you can write in, what was he struggling with? And what did he have? What was his strengths there?
And maybe what did he discover?
Yes, that would be a nice one too. Okay, if you're ready, hit enter. Yeah, I agree with Judy. Slip up with the answer there. Okay. I'll move it on to Jen. Oh, is this still me? This is still me. So group counting, students need to, first of all, learn to use equal groupings or parts to help count large collections. This is one of my sticking points with teachers when I talk to them about counting is sometimes I'll see in worksheets or textbooks or activities that will say to use nickels or dimes to skip count. So for each time you touch the nickel, you actually are counting 5. But when we are actually teaching skip counting, we have to remember the whole goal is to get how many. And so when you are teaching skip counting, it should be 5 objects that they're moving or indicating each time they count 5. It shouldn't be just one object that means 5. That will come later with their sequencing. The other thing with group counting is that they understand that no matter how they count it as a group, no matter what multiple they're using for skip counting, they should get the same result. And too many students that I've worked with are okay with them not being the same result. So again, this is just a self-reflection that Jen will tell you about. I'm just being a hog.
I think, you know, like Deanna had mentioned about the coins, that is definitely more abstract. If kids could understand that a nickel is a value of 5 pennies or whatever, then we could think of using that for skip counting. But often we see games and activities and things going on in classrooms that maybe will cause misconceptions. So maybe you could just in the chat box share if you could think of any examples that you've seen, or maybe if you have your own children and you notice things that you've done or games they play or whatever that might cause those misunderstandings. We could just quickly share those now. I know we have a lot on the counting sequences here in a bit we want to spend some time on, but go ahead and just,
it's worth it.
enter those in there if you see things, or I mean, if you can think of things that might cause these misconceptions.
It usually comes down to the manipulatives that are being used. Pictures.
Yeah. Yeah, if we use base 10 blocks too early, Carol Fullerton always said, do not have them in primary. I agree with her. Yeah, oh, Michelle just added that, base 10.
Yes.
Yeah, those cubes can be very problematic for kids that don't understand counting. Number lines, because they're not objects. Yeah, we're just more kind of, they're just practicing the sequence and the rote counting. Yeah, thank you.
That's a really good point, because later when you have students that are having difficulties with multiplication and multiples, you do need to bring them back to the concrete objects as they're creating and discovering the multiples. Okay, fabulous. And I'll turn this off. All right.
Oh,
So,
I love this one. Actually, I just want to point this, somebody said, when kids don't know how to use the number line properly, so they don't understand that the hop is actually what they're counting rather than just touching the numbers. So yeah, that becomes very problematic. Thank you for sharing that. Okay, go ahead.
And it's spend the time and not to assume that they understand what they're actually doing when they're hopping on that number line, that they are actually touching 2 when they hop to the 2. So the other thing is, within all of these different principles, there's all the different little stages within them. And so one of them is the size of the number. So they may be able to do something at a lower number size compared to a larger number size. And that's part of their development. And that's why our curriculum reflects that. So a student may be able to count to 10, but not 20. A student may be able to count to 109, but not 110. And we'll be showing that later. A student may be able to see 5 as part of 7, but not be able to translate that 15 as part of 17. And a student may not be able to recognize how much if it is a group of 3 objects, but not a group of 5, and that comes down to our subitizing. The other thing is the abstractness that Jen had mentioned. We have to remember that we should be going from the concrete to the abstract. So starting them off too early in the abstract counting can be devastating to their learning. So they really need to work with concrete materials and not symbols until they're ready. And even when they're working with symbols, they need to still be thinking in their head. I say in my class, make a little movie of something concrete when they're doing that. So these are the stages. Again, you're gonna have this, so we're going really fast, and most of you know this. But with manipulatives, you should be starting with the counting of them by actually moving them. Then they move to just touching them. Then they move to just doing it with their eyes. They see them, but they're not actually touching it. And then they can start thinking about the concrete referent. Okay.
Yeah, and then this slide is just about, what is this one about? Children can answer questions or learn to follow procedures, but not truly hold the awareness and understanding of what they're doing. So yeah, we see that all the time, just that following, looking to the teacher, show me what to do, and then them mimicking. And so we want to work on helping them build a really strong foundational understanding. One child might be able to line up 11 objects and be able to demonstrate one-to-one correspondence, but not be able to actually count out the 11 objects when they need to do something with them. So this gets into our a diagnostic called the Get Me task. This one is just where you ask, I would say I would use this in kindergarten, asking a student to get some blocks to play a game. So can you go and get me 7 blocks? And what you're watching for is, do they understand that we use counting to carry out a task? Often we'll just see kids grab a whole handful of blocks and then bring them over and then like pass them out to who they need to, or share them out, or whatever they're doing, whatever the task is. And there's in First Steps in Math, it's called an ice cream task, and it's similar, where they have a group of kids and you ask the students to get each child or kid an ice cream cone, and it's a thing you can print out. But we see kids just like grab a handful rather than finding out how many kids there are, going and getting the right amount and then handing them out. So this one is very telling. I often just tell teachers just to give kids class jobs, like go and get enough pencils for that group and watch, do kids count to see how many they need before they go and get the pencils.
It seems like a very simple thing, but it's really telling of some of the misconceptions they might have in counting.
Yeah. Some students might find the Get Me task quite difficult because there's several things that are going on, like counting, as you can see, is quite complex. So not only do they need to like know the number words and then count out the number of items, but then they also have to monitor for the requested number while they count. So they have to hold a lot in their mind. And so this gets at kind of that working memory aspect as well.
Exactly. And even in grade 5, I look for students who, if I say, can you grab enough paintbrushes for everybody? Most of them will actually count how many kids are here this day and then go get that many. But I do have some that will still pick them up and then do that one-to-one correspondence. That's the way they're doing it.
And then if you have students that don't know that number sequence well, their working memory is taken up with just trying to remember what that sequence is. So then they forget, well, how many did I actually need? So it's quite a task for some kids that have working memory issues.
As an adult, we look at that task and we think it looks so straightforward. What's the point of it? But once you actually see it in action, you'll start to see the differences in your students. So here's another task.
Yeah, so this one is just, we're getting into now just talking about watching to see if kids know their number sequences. And I would say this one, here in Vernon, we use this one a lot as kind of like one of our screeners, but we adapted it a bit to, this one is listening to kids count by ones and then by tens, but we actually check to see that they know counting by fives and twos as well, forward and backwards, because kids really do need to have those sequences when they head into multiplication and division. When they can't count by fives or can't count backwards by fives, for instance, then they will struggle with that later concept.
And very important that they're doing it from different starting points. We want to make sure we do that.
Right.
As well.
Yeah.
Okay, we're going to quickly go through up to and over 100. This is a staple. I don't think I've missed a year. The teachers in our school, we used to do it all the time. And what all we're doing, asking them to do, is actually count out and write the numbers at the same time. So we're not just going orally, but we're actually having them write it down. So what we're looking for, and this will be on every slide, are these different things: being able to count to 1 to 13, 14 to 19, 1 to 9, etc. And you will be shocked by some of the results that you get from your students that you're not aware of. So here with Madison, we have something going on there. And we're just wondering if, again, in the chat, if you could figure out what exactly she's having difficulty with. So I know we could do the strengths and we should be focusing on the strengths, but just for issue of time, what's the thing that she's having difficulty doing? So if you can type that in the chat and then not hit enter until I say. Okay, and hit enter. It's interesting that they're able to do the top part there, but kind of falls apart after 500. Again, for interest in time, where you see her go from 509 to 600, 609 to 700, this is an extremely common mistake. And it's like they get to 507, 508, 509. They're looking for a new number name, and 600 is the next one. It's the same with the place value when you're going 1, 10s, hundreds, thousands, and they want to go to millions. It's that feeling that they have that they need to say a new number, and that would be 600. Okay, and next one. Okay, this is Khan. You check to see if his number sequencing is reflecting the correct sequence.
I didn't catch it. The first part of that is kind of covered up with the chart.
Oh,
That's too bad.
Yes, it is. My bad there.
I think it goes 100, 101, then 121, 131, it looks like.
Yes. Okay, and hit enter. I think Jen just highlighted it.
Sorry.
It's okay. So this is again where we're talking about, oh, wow, he can count all the way to 100. But whether or not they can continue to do that later. And what's really telling, and when you go to the actual link and see the book, it's really telling that he didn't know what to put in that last one there.
I think grade 2 curriculum goes to 100, but I always had my kids working to about 120 just for this very reason. They would get to 100 and then, yeah, you notice lots of different misconceptions after 100.
Absolutely. And when we first learned about this, all of us added more to our number line. So our number line doesn't stop at 100. It went to like 121, just for that reason. Okay, and here we have another. This is Des, and he's in grade 4. Can you find where his mistake is other than the fact that they wrote it right there? But which part of the evidence is he showing? Okay, and hit enter.
One thing I'll just mention while if people are adding anything, when I use this task, if I see students that have mistakes, I always go over and ask them to say the number that they wrote, because sometimes they know how to say it, but they just don't know how to write it. Sometimes they know how, sometimes they'll know how to write it, but often maybe don't know how to say it. So if I think that the understanding is a little bit shaky, I usually do try to have that little conversation.
Yes, and the conversation, that is another developmental piece, is that they may be able to say it, but being able to write it. And so we need to assess those two things separately and together. And you can tell why he's doing that, because we say 81 and we write the 8 and the 1. And so 101 should be 100 and a 1. So it does make sense. That's an overgeneralization for him. Okay. And we want to show you these all to you because it's really important. You're going to be able to see them yourself. So here's Ben. This is a really interesting one. So we're looking for cyclical patterns. So this is all up to and over 100 are all about the patterns and seeing whether or not they understand the patterns which lead to our understanding of place value. Okay, if you can just write quickly what you see there. And the other thing about this is when you do this assessment, you're not going to go through and try to solve all of this. You're going to put them in two piles. They either got it or they don't. So if they have it, that's great. But if they don't, then you know that you need to do some activities that are emphasizing counting. You don't have to go through and analyze everything. We're looking at these closely because we want you to be able to recognize them when you see them.
Mm-hmm.
All right, I didn't say enter, but I think everybody's doing it anyways. But if you haven't, press enter. It's quite an interesting one. Going from ones and then going to tens. And it's very interesting to talk to them about this. This is all of these assessments, this is really important. You don't want to teach them what they did wrong on the assessment because you want to be able to give these assessments again. So perhaps we gave this to Ben at the beginning of grade 6, and then we leave it. We don't teach him, we don't show him what he did wrong. We do a bunch of activities with him, some intervention if we can, and then we give him the same assignment again, the same diagnostic. So you don't want to ruin the diagnostic by explaining the diagnostic. Either I've seen some teachers make the mistake of doing it to their whole class. This is what you should have done. You absolutely do not want to do that.
Or send them home. We don't send them home.
No. Yeah, this is for you. This is your formative assessment to see where you're at. So, and now we have Lucy. Lucy is similar to the other ones, but a little bit. This is grade 2, so not as shocking as the last one for grade 6. But if you can, again, in the chat, just write down. Jen and I are wanting to go back and look at your answers.
These really show how much counting underpins place value.
Mm-hmm. Which underpins everything else.
Yeah.
So definitely if we gave Lucy a test and had her a diagnostic count to 100, we would think she's got it, pretty good. But obviously after 100, it falls apart. And that's why it is important to go past 100.
Yeah. There's a comment here. I'd like to hear her count. She may just not know how to write 103. So she writes 100 and then 3.
Exactly.
But she may know, she probably does know how to say the numbers. She just doesn't know how to write it.
Yes, and a perfect example, if you bring in these and you have a whole group, you can do a small group of reinforcement of the difference between the saying and the writing. And it's something you can teach explicitly too, like watch the way I write 108. What do you notice? It's things you can do later about that. Okay, so those were the big ones there. For the older grades, this is one I use at the beginning, in the middle, and the end every year in my classroom. I used it even when with higher grades. And this is a nice one to show the counting on the number line. So they're having, again, this is for higher grades that are used to using number lines, but their understanding of counting from 9 to 10, and this introduces the decimals, the parts of a unit. So that one is fantastic to try. Very revealing. Did you have anything you wanted to add on that one, Jen?
Nope.
Okay. And clothesline. So we've heard a lot about this. We've been doing this for years, and now it's been coined, clothesline, when you have kids put things in orders. The great thing about if you get the clothesline book or go to the website, is the collaborative part of it. So having students doing this together and then talking about anything that goes wrong on their clothesline. So that's one thing you can try. We just wanted to leave you with a couple things that really work. This is indispensable, the clothesline activity, when you're doing decimals and fractions, and whether, yes, anyways. And then
can you just go, I just want to add one more thing that I've done with this one for kindergarten, is I've made like little baggies with items in them, or even just cards with stickers so that they connect quantity to numbers. So, like if you've seen when you stack the cards on the clothesline. So that's just an idea to kind of extend this a bit and get at that connecting symbolic to quantity.
That's the next one, because right now we're just in the abstract with this. And so remembering if a student is having difficulty with this, that you need to go back. So the concrete, whether or not they're putting the amount on there or not. Jen, you had a little, oh, no, I think I was telling you about that. So there is a difference about counting, and I've seen people make little cups or use egg cartons or things like that. And then the teacher is labeled 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the kids come up and they put 1 in there, and then they put 2 in the 2 one, and they put 3 in the 3 one. But what you've created when you've done that sequencing is you've created a number line, a counting sequence, but it's not working because a child will then think the 2 is the 3 and so on. So if you are doing an exercise where you want them to count the number, like they're going to put the little animals in the cup that says 5, and they're going to put 5 animals in there, make sure it's not in a sequencing format, that you're developing a misconception about counting, because again, we should be counting for how many. So if he says, oh, I'm on the 3rd, like I'm on number 3, but he's putting in 3 and he has 6 in total now. Those are the things that we have to be aware of when we're modeling or giving our students activities. And our favorite, we're ending with our favorite.
I think it's Andrew Stadell that has the clothesline math. I think if you just, somebody asked what the resource is for a clothesline activity. I think if you just Google clothesline math,
it is,
but I think it's Andrew Stadell, yeah. I love this
my favorite
activity. Oh yeah, and Chris Shore, thanks Alex. Using the constant function on or having your kids use the constant function on a calculator to help them learn the number sequences is like magic. I've tried to show kids, have them go to the number line, have them write numbers. But I found that when you use the constant function on a calculator and have them predict what number comes next and then hit the equal sign and see that number come up on the calculator, it's like just suddenly the light bulbs come on for them. I had a boy in grade 2 one year who was just not getting the sequence, because I always did that up to and over 100 with my students, and thought, okay, well, I'll give him. I knew he would love the calculator anyway, but he drew me a picture the next day and wrote the sequence correctly because he was so excited that, okay, this calculator has told me how to do this. Too funny. But basically what the constant function is, if you don't know, you just type in whatever number you want them to start counting at, and then +1, and then they just keep hitting equal, 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 and it'll just keep counting up for them. Was I going to say something else about that? I think that's it. Oh, the other thing that I've noticed too when I see kids making mistakes on the up to and over 100 is I'll write out what numbers they've written, and then ask them to take that either using the constant function or go to the number line and figure out and say to them, figure out where your mistake is.
Exactly.
And that's helpful too.
And it is so true. We wrote on the bottom that the students will frequently believe the calculator more than the teacher, and this is 100% true. They may not believe you that 109 goes to 110, or you'll say it till you're blue in the face. But if you put the calculator, which is a novelty, so you've sparked all this learning juice in their brain already, and they see that when they go 109 and they hit that equal sign and it goes to 110, their face is just amazing how they react. One little clue for this, or a hint on this: make sure that they are not holding the calculator in their hand. Make sure it's always on the tabletop, because they always mess it up. It's just amazing. That's just one of those little clues to make it work every time. And you can do this whole class. I do this whole class with decimals. So when we're learning how to count with the decimals, because so often I have students that will go 0.09 and then 0. Oh, see, now I'm all messed up. Or 1.12, and then they'll go 1.21. They'll start to mix up because their place value isn't straight there. But one of the ways to help with their place value with the decimals is the counting part of decimals, and number sequences on the calculator really help them see that. So that is one of the ways that you can not solve, but help move them. to a better understanding of the up to and over and counting through the hundreds and through tens and through ones is to use the number sequences and the clothesline activity. So I think that's it, right, Jen?
We are at the end, yes.
Wow, I'm going to stop sharing this because it took up my whole screen. I couldn't see anything. So I really hope that this sparks some curiosity about what your students can do in your classroom. And again, it comes back to that taking for granted or assuming that they have this counting understanding because they're able to count things for you and you hear them counting. And just digging in a little further with these very, very quick assessments can reveal a lot of misconceptions that you can help solve right then and there so that it doesn't keep growing and snowballing into the other grades. And if you're an older grade, really counting's the first place you need to go back to. If they're having difficulty, especially with their basic facts, what is going on here? That's usually what we're doing. What is going on? Go back to counting, see if they have the concepts, the principles of counting down and solid for them. One last thing, if you're doing something really quick, the conservation, the count, you just grab like a few things, have the kids count them, put it in your hand, shake it, move it around, put it on the ground, put it on the table, move it all around, and then just put it back in front of them and say, well, how many are there? And if they have to count it again, you know you have an issue there that you have to solve. It's probably one of my quickest ways of seeing if I have to dig a little deeper into the counting. So I think that's about it. So we're going to open up to questions. And I think at this point we should we stop recording or should we continue recording? What do you think?
I think we can just leave it recording.
Okay, sounds good. Very good. Okay, does anybody have any questions? They might be all dead now. We might have made them, their brains are all numb.
Our next session is going to be on partitioning, I think.
Yes, systematizing and partitioning, and that'll be in 2 weeks. So we'll be moving on to how important those are. And again, we'll be saying that that underpins everything as well.
Somebody asked, where do I find FISM? We will post a link on the BCMT website, but you can also just Google First Steps in Math resources, and they're free online. All of the diagnostics are in the course book, but then there are also resource books that have tons and tons of activities to help you know what to do when you do see these misconceptions.
Absolutely. Let's see here. I think that is the link, everyone, to our Google Drive that we will continue to add things to as we find new things. Cynthia's asking if it's the same link for the next session. No, it will be different because we will have other people that will be signing up as well. Might end up being the same. That would be Colin, but I think Colin's gone. But we will do the same thing as we did last time. We will take all the people who have registered and we will send you the link the night before. Just gonna see if I can do that link to the, like Jen said, if you Google First Steps in Mathematics, especially if you say Pearson afterwards, it'll bring you right to there. And you will actually see that they have it for literacy as well. They have it for measurement. They have it for, they have stuff for fractions. I think we made our own, but please reach out. And we really hope to see all of you at our next session. Are we good?
I think so.
Excellent. Well, that went really well for our first time trying to explore all of that.
Thank you, Colin, for helping.
Yes. Thank you all for coming. And do go to the BCMT website. This should be on there by the weekend, and you can watch all those videos again and share them around and share what you've learned with people at your school. Okay, thank you.
All right.
Bye-bye.
Bye, everyone.